Okay, last video we have learned how to construct a enthalpy change cycle, and we find that some of the question will be a little bit more challenging. They have 4 equations, so that we have to form a square for the enthalpy change cycle. So this video we're going to learn how to deal with the same type of questions without constructing a enthalpy change cycle. I'll just call this one statement form, because I just have different statements of different equation. List them out to help us to solve the question. So for the statement form, the skills that we're going to do, first, we will reverse the equation. Sometimes we may need to reverse the equation, but when we reverse the equation, we also reverse the sign, Say, for example, we have H plus OH minus becomes H2O. For this one, it will be delta H will equals to negative 57. But if we reverse it, say for example, for H2O, we break it down into H plus and OH minus, So this one, delta H will then become positive 57, And then sometimes we need to multiply the equation. When we multiply the equation, we also multiply the value. Say for example, we multiplied the equation above, so we have 2H2O to break down 2H2O, and then we will have delta H equals to positive 57 times 2, And then, we will have to focus, on the ionic equations, or ionic chemicals. Say, for example, in some of the equation, we may have like Fe2O3, and then O2, and then blah, 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 things like that, So in this case, Fe2O3 will be more special. So I will focus on those ionic chemicals like iron 3 oxide in this case, but not O2 in this case. Because most of the equation, O2, will be part of the things that we add up, to help the equation to get balance. Number 4, we are just like previous one, the skills, Each of the equation will use once only. Some of the equation may not be used, but most of the time, each of the equations have to be used once, So now we're going to deal with class practice 55.2. Question number 1 again, This video, I'm going to use the same questions, So that you can see that you can either choose to use enthalpy change cycle or the statement form, So how are we going to do the statement form questions? So basically, our target, is to use these 3 equations and make up this equation, So we're just comparing with the chemicals in this equation with these equations. Say for example, we can see that our ultimate goal, we need 2 carbon on the left, and then I will find that in statement 2, we have graphite there, So I will try to have this coefficient the same as this one. So therefore, for equation 2, I have to multiply this one by 2. So we'll have the first statement like 2C plus 2O2 become 2CO2, and then this one, will then be negative 393.5 times 2. So we finished the first one. Next, we're going to aim at another chemical. Say, for example, we have H2. For H2, we have 3 here, but for equation 3, we just have 1. So therefore, for equation 3, we're going to multiply this one 3 times. So when we multiply this one 3 times, we have 3H2, 3 over 2O2, and then we have like 3H2O. So for this one, this is number 3, so it will be 285.8 times 3. Last one, we're going to deal with say for example, we have the ethanol here, So this one, ethanol, we have ethanol here as well. But you see that, for equation 1, the ethanol is on the reactant side, but our target equation is on the product side. So what I'm going to do, I'm going to reverse equation 1, So therefore, the sign, have to be reversed as well. From negative 1,371 become positive, So what I'm going to do, I have to be very careful, reverse the whole equation. So we'll have first, we'll put these product, on the left. So we will have like 2 CO2 plus 3 H2O. And then will become the reactant side with these things, right? So we'll have like C2H5OH plus 3O2. So the delta H that we have this time, will become positive 1371, 1371. Okay, so after you put three equations, okay, align, okay, put them on the corresponding places, okay, then we try to add these things up. Okay, so you'll find that, okay, some of the O2 will be cancel each other, some of the H2O will be cancelled. Say for example, you can see here 3 H2O on the left, 3 H2O on the right, 2 CO2 on the right, 2 CO2 on the left. Okay, and then, okay, the oxygen that we have, you can see that we on the left hand side we have 3.5 O2. Is that right? 3.5 O2. But on the right hand side we have 3 only. So therefore in this case, okay, we'll try to eliminate the O2. Okay, only having half O2 left. So after we add all these things together, so we'll try to have 2C, 3H2, and also half O2 on the left hand side. And the product side we have the ethanol. Okay, so we'll have 2C, 3H2, and then half O2, and then you have the C2H5OH, which is exactly the same as our target equation. Okay, so like what we've done before, we'll just say by Hackett's law, we'll have like negative 393.5 times 2 plus negative 285.8 times 3, and then plus 1371. Okay, so this one will then be equals to the delta H. By doing so, okay, you'll find that the delta H will equals to negative 273.4 kilojoule per mole. Okay, so this is how we use the statement form to help us to solve the problems. So now we're going to do question number 2. Okay, so this will be the equation that we have to mimic. Okay, so we try to focus on the characteristics of the iconic chemical first. So in this case, we see Fe2O3. Okay, so we found which equation have Fe2O3. So the first one we have Fe2O3. So I'm trying to multiply with the first equation by 3. Okay, so this one I have going to times 3. So we have 3 Fe2O3, 9 CO, 6 Fe, and then 9 CO2. Okay, after you finish this one, I'm going to pick the other one. Say for example, this time, okay, I try to have Fe3O4. So Fe3O4, we see this one. Okay, so they are on the same side. Okay, what you need to do, just multiply this one by 2. Okay, multiply this one by 2. So the next, okay, you're going to multiply it. Have 6 FeO, 2 CO2, 2 Fe3O4, and then you have like 2 CO. Okay, so finally, okay, you have question number 3. Okay, the equation 3. We can't see any Fe here. Okay, so this Fe must have been cancelled out. Okay, from one of the equation above. So we see that we have 6 Fe on the right hand side. So basically this equation, okay, we will have to multiply this one by 6. Okay, multiply this one by 6. So you have like 6 Fe, 6 CO2, 6 FeO, and then we have 6 CO. If you do so, you'll find that 6 FeO and 6 FeO can be cancelled out. So now, okay, we try to have, we finish using each of the equation ones already. So we try to add them up together. So the ones are the same, we have to cancel out. Okay, so we have like 6 FeO on the left, 6 FeO on the right, 6 Fe on the left, okay, 6 Fe on the right. Okay, so we try to add up all the CO2. So we found that we have 8 on the left, okay, 9 on the right. So therefore this one, okay, we should have 1 CO2. Okay, so for the CO, okay, we'll find that we have 8 on the right and we have 9 CO on the left. So therefore we have 1 CO on the left. So leaving behind, okay, we have like 2 Fe3O4, we have 3 Fe2O3. So this equation will be the same as this one. Okay, so again, you have to use by Hackett's law. okay, delta H will equals to, okay, this time we'll have like negative 11.5 times 3 plus, okay, we have positive 9 times 2, and then you have plus negative 0.5 times 6. So by doing so, you'll find the answer should be negative 19.5 kilojoule per mole. Okay, so actually, okay, by using statement form, you'll find that it is easier to do. Okay, but you have to still learn the way how to construct an enthalpy change cycle, because that will be some of the questions they may request you to do the enthalpy change cycle to demonstrate to them. So both method you have to learn how to do it. Okay, so just give you a few more examples. For example, okay, in example 35.6, okay, so this one, okay, we have 5 equations. So if you really need to construct a enthalpy change cycle, that would be quite complicated, okay. But using this method, okay, it seems that it will be easier, okay. So we have like the first one, okay, we'll try to have SO2. Okay, so you just go through all the equation, you find that SO2 will be this one. So what we're going to do, we have to reverse, because this will be the reactant side, this will be the product side, so you have to times the negative one. We have 2 here, you have 1 here, so what we're going to do, we'll have this one times negative 2. Okay, we have to times negative 2. So we have like 2 SO2, 4 HCl, and then become 2 SOCl2. Okay, and then you have 2 H2O. Okay, and then next, okay, we have the P right there. Okay, so we find P here. Okay, so P, we have 2P. So amount the rest of the equation, this one have P. Okay, but you have to multiply this one by 2, right? So this one have to multiply this one by 2. So you have 2P plus 3Cl2, and then like 2PCl3. Okay, next, okay, we have the Cl2 issues. Okay, but Cl2 we have quite a lot. Okay, maybe this one Cl2, I will skip this one first, because you see that this one Cl2, this one Cl2. Okay, so maybe a little bit more complicated, so I'll just focus the other first. So we have the SOCl2. SOCl2 we have done it already, because we do it already. And then we have POCl3. Okay, we have finished this equation. So the SOCl2 we can just skip it first, okay, to see what happened later on. Okay, so next, okay, we have like POCl3. Okay, we haven't done this one first. Okay, POCl3. So they are on the same side. Just multiply this one by 2. Okay, so this one have to multiply by 2. So the second equation will be 2PCl3, and I have O2, and I have 2POCl3. Okay, so we've finished most of them. Okay, so leaving behind, we finished all this already. So leaving behind, okay, that will be the HCl issues. Okay, HCl, you can see that actually we have HCl here, but at the ultimate equation we can't see HCl. So therefore, what we're going to do, we have to eliminate this HCl. But this HCl is on the reactant side, left hand side. This one is also on the left hand side. So what we're going to do, we have to multiply. You have to reverse this equation and multiply this one by -1. Okay, so this one, okay, we'll have to multiply this one by -1. So we reverse it. So you have a 2Cl2, 2H2O, and then you have like 4HCl, and then O2. Okay, so now we try to add all the things together and see what do we have. Okay, so add all the things together. So we have 4HCl cancel out. So we have the H2O cancel out, and then we have PCl3 cancel out. Okay, so leaving behind, we still have O2 cancel out. So we have SO2, unique one, P, unique one. Cl2 right now, you add together will be 5, okay, just the same as this one. We have 2SOCl2 and 2POCl3. So just make, okay, should be just make, okay. So you have like 5Cl2, and then you have like 2SOCl2, and then 2POCl3. Okay, so just check the equation here. It is exactly the same. Okay, so what we're going to do, okay, we have to be by Heck's law. Okay, delta H equals to positive have to change to negative. So the first one will be -20. Okay, plus you have negative 326 times 2 plus negative 307 times 2. And then this one have to be reversed. Is it reverse? I forgot that. Okay, have to be reversed. Okay, so this one should be negative 1. So we have to plus positive 203. Okay, so by doing so, you should be able to find the answers equals to, this one should be equals to negative 1083 kilojoule per mole. Okay, and you can check the answers, okay, in the textbook. Okay, they will do the same, okay, but in the process they have a lot of explanations. So you see that some of them may be like reverse equation 1, okay, so you have to see that after we reverse become negative, okay, but this one is not enough. You have to multiply this one by 2, okay, so you have a lot of things to follow, okay, in the process. Okay, so you can just go through here, okay, but more or less, okay, the most important part should be here. Okay, in the public exam, okay, if you are not forced to use enthalpy change cycle, you may also use this equation. Just list out something like this and then say by Heck's law, and then do the math afterward. Will do. Okay, so class practice 35.4. This one is extremely easy. You see that the CA, so you just have the CA equation 1, okay, written down like this. And then, okay, this one is just times 1. And then you have the H2O. So one on the left, one on the right. So this one you have to multiply a negative value, and you have 2 here, so you have negative 2. So you just have like 2H2O, okay, and then become 2H2 and O2. So what you need to do, just add them up together. You find that you can cancel out some of them. Okay, so you have like Ca plus 2H2O become calcium hydroxide, and I have 1H2. So the delta H, remember by Heck's law, okay, the delta H will then equals to negative 985.2, okay, and then plus, remember all the time must be plus in the middle, so it will be negative 285.8 times negative 2, okay, or you can just change the sign to positive 285.8 and then times 2 will be the same. Okay, so at the end it will be negative 413.6 kilojoule per mole. Okay, so it should be the same as this one. Okay, so that's all, okay, for this calculation. Summarize, okay, the skills for statement form. Sometimes you may need to reverse, but remember you have to reverse the sign. When you multiply the value as well. Focus on the iconic equation. Don't try to look at the O2 or like Cl2 or CO in some of the cases, okay. Every case will be different, okay. You try to find the eye-catching chemicals. You focus on that first, okay. And also remember, each of the equation we only use once only, okay. So these techniques is great to do MC questions, okay, because you don't need to construct enthalpy change cycle. I think statement form is easier than the enthalpy change cycle, but you still have to practice the enthalpy change cycle, because in a public exam they may require you to do that, okay, and it will just like having 2 marks on that or 3 marks on that, quite a lot already. Okay, so that's all for this video. Bye bye.